A linear inequality in two variables has the form ax plus by less than or equal to c, or ax plus by less than c, or ax plus by greater than or equal to c, or ax plus by is greater than c. Basically what you see here is that everything's linear because the variables x and y are raised to the first power, and a, b, and c are all real numbers where a and b can't both be 0, but one of them can be 0. So what we need to be able to do is to be able to graph these inequalities and see what they look like. So let's start out. Let's graph the inequality x minus 2y less than or equal to 4. This has the form that we just talked about with a equals to 1, b equals -2, and c equals 4. So to graph an inequality, the first thing we do is we graph the equation that corresponds to it. The less than or equal to that we saw in the inequality, we're going to replace and write it as simply equal to. So the easiest way to do this is on your calculator, but there you'd have to solve this for y, and that might take a little bit of time, or by finding the intercepts. So I've gone ahead and started a table here, and x equals 0 and y equals 0, and then we have to find the other variables. So if x is equal to 0 and we put that back into the equation, what we see is that we get 0 minus 2y equals 4, which means that y is equal to -2. So this is the ordered pair 0, -2. Now if I go ahead and put y equals 0, I get x minus 2 times 0 equals 4, or x equals 4, so that's the ordered pair 4, 0. So now that I have those ordered pairs, I can go ahead and graph the line that goes through those two ordered pairs, and that's what you see in purple here. You see the point 0, -2 along the y-axis, and the point 4, 0 along the x-axis. So the solution to the inequality is all the points on the line, because I see that there's an equals in this inequality, and either the points that are above the line or below the line. To determine which side is the solution, we're going to pick a point from one side and then substitute that into the inequality. As long as the line doesn't go through the origin, probably the easiest thing to pick is the point 0, 0. If I put 0, 0 in for x and y, I get 0 minus 2 times 0 is less than or equal to 4, or 0 is less than or equal to 4. That's a true statement. Since that's a true statement, that means the point that I've just found there is a solution, and in fact, every single point on that side must also be a solution. So I'll go ahead and shade that side of the line, and also I've gone ahead and put the border here in dark black, because since that included an equals, the line that we originally drew, which corresponded to equals, must be included in the solution. If it wasn't included in the solution, I would have gone ahead and drawn it with a dotted line instead. So now let's take a look at another inequality. So this is a line in slope-intercept form, so it's going to be easy to graph. So I've gone ahead and drawn that line here in blue. And in the previous example, we tested at 0, 0, but I can't do that on this particular one because 0, 0 is actually on the line. I'll have to pick something else to do my test at. So where I'm going to pick is at 1, 1, and now when I go ahead and put 1 in for y and 1 in for x, that's a true statement, so that means everything on that side of the line should be shaded. What makes this a little bit different from the previous one is this does not have the equals underneath it. So what that means is when I look at my border here, I'll use a dotted line to indicate that the border is not a part of the solution.